Here's how to solve a different type of 2D projectile motion problem in physics. So in this example, we have a baseball being hit at a speed of 45 meters per second at an angle of 16 degrees, and we're asked to figure out if the baseball will clear the 2-meter tall fence that is 100 meters away and score a home run. Now I know there are a lot of numbers in this problem, but here's a general strat to make it easy. Anytime you have an object moving in both the up, down, and the left, right direction, the key is to write out the kinematics equations separately for each direction. Then you solve for the time t in one direction and plug in the same t into the other one. In this case, we're looking for what the y position of the ball is when it makes it to the fence. If the y position is greater than the height of the fence, 2 meters, then it's a home run. This y position will be related to the time it takes for the ball to move in the x direction, from home plate to the fence. Now, choosing which kinematics equation to solve with, we're going to use this second equation, because in this problem, we're not given, nor are we asked to find the final velocity. The next step is to write out our kinematics equations in each direction. Now, when writing these out, you'll notice that there are two initial velocities, one for the x direction and one for the y direction. However, in this question, we are given only one value for initial velocity, 45 meters per second. But this is a velocity that points in both the x and y direction. The trick here is to break up the initial velocity into separate x and y components by making a right triangle and using trig functions. So here the initial velocity in the x direction is 45 cosine of 16 degrees, while the initial velocity in the y direction is 45 sine of 16 degrees. Next, we plug in for the variables we know and see how to solve for the variable we don't know, which is the final y position. Starting in the x direction, we're looking for when the ball has made it to the fence, so x final is going to be 100. We're then going to call our initial position equal to 0 and plug in our value for the initial velocity. Looking at the acceleration in the x direction, this is also going to be 0 because there are no forces acting on the ball in the x direction, and by F equals ma, if the net force is 0, so is the acceleration. Now looking in the y direction, our final y is what we're actually looking for, while the initial y is equal to 0. Again, we plug in our initial velocity. But looking at the acceleration, we are now going to use negative 9.8 meters per second squared. This is because any object moving freely through the air is going to feel a downwards acceleration in the y direction due to gravity. After simplifying a little bit, we have two easier equations where we can solve for the final y once we have the time t. This is where we're going to use our x direction equation to solve for t, since the time that the ball takes to travel in the x direction to get to the fence is the same time when we can determine if it is above the fence by calculating y final. Solving for t, this gets us t equals 2.3 seconds. The last step is to plug in t equals 2.3 to our y direction equation, which gives us a final height of 2.6 meters. Since this 2.6 meters is higher than the height of the fence, 2 meters, this means the ball will clear the fence and it's a home run. And there you have it. That's how to solve another 2D projectile motion problem in physics.
Nice!